Hey guys, welcome back to Better C Sharp. This time we're going to be talking about a super important topic, and that is refactoring. So refactoring is the practice of modifying code in such a way that it does not alter its behavior. And this lets us change the structure of code and even the algorithms behind it without modifying the external behavior of that code. And this is a necessary step after getting it working, right? So you've got some code, like your manager's like, hey, we need this thing to do this, and then when you're done with it, go ahead and double the result, and then that's that. And like you have some code and you wrote it and you've got it all in one method and it works, and you commit it. No, you don't commit it. You have to refactor it. Like, you need to make sure that it follows the s.o.l.i.d principles, that it is easy to read, easy to maintain, that it doesn't have any crazy comments that say something that's not even true. You gotta make it ready to be checked in. Getting the code working is just the first step. So uh, if you don't have a code review at your place, you should probably be your own code review on this. But anyway, so this is a necessary step after getting it working. Too many times code is left after the just got it working stage. And you guys know what this code looks like. You've seen this code everywhere you've been, and you've had to clean up this code by rewriting it every time you have to work on it, right? So I've got an example here. Imagine if a car company, they just had the engine sitting on the roof. And I realize that's not like applicable. That's not probably mechanically very possible. But well, let's say it's a battery powered car, and they have like all the battery electronics stuff sitting on the roof of the car to make it easy to swap in and out parts. And then let's say that they got it working and they're like, okay, it's working. Let's just give it to the customer. They're like, no, that's not how things work. Um, that's what it's like though when you commit code without refactoring it to get it into a state that's maintainable. And if you're doing that, stop doing it. There's an easy solution. Just go back, look at your code, refactor it, then check it in. If you have code reviews, this should be something you look for. Like, if you're giving other people code reviews, don't let them check crap in. That's like not good. Like, don't let them check it in if it's going to be a maintenance nightmare. Like, give it back to them. Like, give them reasons. Like, these are objective reasons. Like, it's not following the open close principle when we want to modify this to have a new implementation of this thing. Like, it's going to be a nightmare. It's not, this comment says it does this, but it doesn't do this, whatever. Just talk to them about it, give them objective reasons why it's not good, and let them fix it. And, you'll both be happier once it's fixed. If you don't have code reviews and you're responsible, like, for checking your own code before you commit it, check it. Like, don't just get it done and then commit it. People that are still taking programming classes can get it working. Like, if you're, a software developer being hired by somebody, like, you need to be above that. You need to not only get it working, like, it needs to be good. Be proud of what you write. And part of being proud of what you write is like taking responsibility for the maintenance down the road. Even if you're not the one that's going to be doing it, you need to be nice to the people that follow you. And even more so if that person is you. Like, it sucks. Like, when you write some code and you come back to it a year later and you're like, oh my gosh, what does this even do? Where does this start and end? And then down here we've got another one. Like, if you keep adding stuff onto an existing code base, like, without refactoring it, like, you've got this thing that works and your manager's like, okay, we'll just add one to it. And you go in there and you add one. And then they're like, okay, well, now we want to divide it by 3. And you go in there and you divide it by 3. Like, if you do all this stuff without like refactoring it to make it better, ultimately it's going to be this long, like, convoluted thing. If you don't refactor, it's just going to get hard to work on. This is how projects lose speed, and this is how projects ultimately get rewritten, is people that go in and they just add some code, add some code, add some code. They don't ever restructure things. They don't rename things. They don't modify things. Like, they just add and add and add. And then, like, before you know it, you've got a 6,000 line file where, 2,000 lines of that are duplicated code because you didn't want to change anything that already existed. And, like, a big part of that's probably not having unit tests and stuff like that. So that's one reason unit tests are important. But like even if you don't have unit tests, like refactor stuff. If you're copying and pasting from up here and putting it down here and you're like, okay, we're gonna do it slightly different now for this type instead of this type, like I just don't. Like refactor it. Like that needs to be a separate method and you call it with different parameters. Like just refactor your stuff. It's super important. Like this is what separates good developers from crappy developers. Like you want to be a good developer, you need to make your code good before you check it in. Anybody can make it work. A monkey can make it work. You want to make it good. I realize I'm a little bit passionate about this just now. So it's something I'm passionate about. I want to work on good code. I want to keep good code. Refactoring is something I'm actually very happy to do myself. So like, when I see code that's bad, like I can't leave it that way. I have to fix it. And does that slow me down on current tasks? Yes, but it speeds up future tasks. And those tasks might not even be mine. Like, what if, a developer that's not as familiar with the code comes behind me and has to make modifications? Since these things are refactored, it's going to be that much easier for them to understand it than this 6,000 line monstrosity, right? So you got to take care of your code. So I've got some examples here. Probably the one that I see the most is methods that do too many things. And they do too many things at different layers of abstraction, right? So like this thing is supposed to get a count of words from something, and you see something, the definition of it up here, right? So it's got an ID and 2 strings, and we're trying to get a word count out of it. And we're supposed to get this thing by ID, right? So like this method, it just does too many things, right? And so like it's constructing something, it's going and getting something, first part from a file, the second part from some web server, and then it's like doing this logic in here, and then it looks like maybe this got copied and pasted down here or something to add more of it. Like maybe they only wanted the first part at some point, and now they want both. This is like methods that are like this end up being nightmares. Like this one's fairly simple. It's only, however many lines. How many lines is this? This is, let's see, 36 lines. You see down there at the bottom right? Like this one's fairly benign, but like already it's more than a page. And if somebody wants to modify something here, the way it's structured right now, they're just going to add to it. Like they're not going to make this any better than it is. So it's up to you when you do it to make it better. And really what this should be is like, all of this should be, maybe one part of a method, right? And so like, maybe it's called get something by ID, right? And then this part is like, we're getting the counts of the words, right? So, but you can see like these 2 sections of code. So like from here to here and from here to here, these are very similar pieces of code. The only thing that's changing are the first part. So this should also be a method that we can extract, right? So, something like that. And maybe we don't want to take in these guys, but, maybe we want this to be something like get word count for part or for string or whatever, and so this could be record dot first part and then delete till there. Oops. Yeah, sorry. And then maybe in here we just want string part or whatever. So part dot length or whatever. So and then part, right? And then we'll do something like word count 0. And so now up here, this is like that. And then we can do the same thing right here. Word count plus equals get word count for part, and then record dot second part, right? And then if you look at this, like this is way better. This reads exactly like the way you would think, right? And what you'll notice is like what we did is we took some code that had a comment above it, right? Add up the words in each part by looking for spaces. Like anytime you see a comment that's like describing what the code does below it, a lot of times that's like a red flag that should be like, this code below it should be abstracted and that comment should be the name of the method, right? So like, we didn't do it this way, but like if this was right here and this said, get words for part 2, like that's what we should name the method, get words for part, and pass in part 2, right? So yeah, word count plus equals get word count for part and record that part 2, second part, or whatever. So now, but this thing does, like this reads the way it should read. And then even get something by ID, like we're doing, like this, I would probably let this one slide, but really these two should also be methods, right? Like I would think, like, because they're at different levels of abstraction. Like at one level, we're creating our something, and then at another, we're like reading files and reading HTTP requests, right? So like that's not, these are at different levels. So I would probably abstract these out too. So, maybe something like, you see the comment, get the first part from file, right? So let's extract a method and, name this thing, right? Get first part, right? And then, we just pass in the ID and say record dot first part equals that thing. And there we go. So now we've got the first part here. And this doesn't need to be void. It needs to be string. And this just needs to change to the equals return. Okay. Right? So that's basically, we don't need this comment anymore because the code says what it does. And we're going to talk more about comments in a minute. But let's go ahead and do the same thing. We're just going to extract another method here. We're going to get rid of that and just say record.second part equals this thing. Let's rename this to get second part, right? And we'll say change to the equals return. And this needs to be a string. And this didn't get picked up. Second part, and there we go. So now this like already reads way better, right? Like all of these things are at the same level of abstraction, if that makes sense. Like we're saying like get first part, get second part, where we're like building something. We're not like opening a file anymore. You know what I mean? And so what you'll notice is also there's another thing I set up here that a method should contain one level of abstraction, and that level should be exactly one level below the name of the method. So like get count of words, everything in here should be one level of abstraction below get count of words. So like get count of words is like a thing that you can do, but then each of these things needs to be just one level below that. Like get something and then count the words. You know what I mean? So hopefully that makes sense. Let's go look at data mover. This one's a fairly simple one. It does too many things. So basically, this is violating the single responsibility principle. This should be two different classes. Like we should have some data loader and some data sender instead of doing two things in one. We would probably want to extract an interface for this thing. And then, we probably want to move this to like another interface, right? And so like you would want these to be on two different things, because if you wanted to change how you load data, you're going to be messing with the same code that sends data, and that's not good. So this is, violates single responsibility principle. So that's a fairly easy one to talk about. Let's talk a little more about comments. Comments are generally a bad thing in code, in my opinion. They should only really ever tell you like why you do something, not how you do something. And so like, and even then, like you have to be careful because they can lie to you. And so you guys might see this right here, like, we should return early if the file name is test, and that's not what this code does, right? Like these are swapped. There should be not equals. And so like the comments can just lie straight to your face. And the thing is, like, this code might have been correct at one point. Somebody came in here and maybe changed this to a double equals because the logic was wrong, and now the comments out of date, and nobody fixes comments. Like that's just not something that happens. Comments are like a color that you already ignore, and like they don't get compiled with the code, so they can't be checked unless you're using Rust, which that's cool. But like the language in a comment cannot be semantically checked, right? So comments in general are just bad. You should just have code that like does what it says, and have your code say what it does. Another thing on that note is something like this. You see this a lot in older code bases that were eventually moved into source control that were not originally in source control. But like anytime like you see something like this, just delete it. Seriously. This is what source control is for. Like you need to have commit messages that describe what your changes are. We're going to do a video on source control and like best practices on that very soon. But this should definitely be something that's in source control and not something that's in a comment, because like the comment's lying. Added 1 to the sum, that's not what happened. Like the sum is adding 3. Somebody came in here after TD and added 2 more to it, right? And they didn't update the comment, because why would they? The comment doesn't get compiled. Like it doesn't, there's no compilation error for a bad comment like this. So comments are bad, just don't have them. And on that note, if you have commented code, like if this were like this, delete that too. Get that out of here. Like that code, all it does is serve to distract. And like then when it's more cognitive load, when you're coming through here and you're like, why is this like this? Why is this commented out? Did that commented out code ever work? Does it matter that it's commented out? Was it an accident? Like just delete it. If you see it, delete it, check it back in. Like don't let it come back. Like let this code die. Let's see, we're going to go on to the next thing. This is names. Names are super important. I'm going to read this, but you guys can read it as well. Names are incredibly important. The example below is a pretty clear example of why that is the case. Even though the logic is simple, even without the names, it doesn't show intent. Having the names shows intent, and I'm sure there's plenty of other logical problems that this class could solve than the one we chose to use it for. So I'm going to give you guys an example. We've got this class A, we got this read-only int y, we're taking in an n, we're assigning it to y. Like none of this makes any semantic sense, right? But as soon as you change this to be like age checker, right? And then like, minimum age, and this right here to minimum age, and this right here to has ID, and this right here to age of person, then we can name this can purchase alcohol or something like that, right? Like did that work? Okay, it did work. Like now this code shows intent. But the interesting thing is, like, without the names, it doesn't show intent. So if you're coming through code and if you see bad names in the code, rename things. Like, give people better hints. Like, don't let people get away with bad names in code. Rename them. It's up to you. Like, clean up the code. And in fact, like this, what I was mentioning with could solve more than the problem. Like, what if this was like, something like red line indicator, right? And this is like, minimum RPM, and same thing here, minimum RPM, and then engine is on, and current RPM, right? Oops. Like this describes a completely different problem with the exact same logic, right? And so the names are super important to give you info about what your code is actually talking about, because otherwise it could be talking about anything. This could be talking about, selling alcohol. Oh, this needs to be changed. Should show red line indicator, right? Like this could be talking about red lines in an engine. It could be talking about selling alcohol to an individual without ID or with ID. Like it just, without good names, there's literally no meaning. at all. So name things well. Don't let people get away with bad names. If you see bad names in code, rename them. All right. Let's go to the last one that I have here because we're getting pretty long. So you should not have magic constants and strings like around your code base. Like this right here, this one right here. So logic in programs that compare magic constants or magic strings is a recipe for hurt when those constants and strings inevitably change. And they will change. Or the reason you use them will change. Or like things about them will change that cause you to have to look around your code base for the constant one. And you don't want to be looking around your code base for the constant one. It's not fun. Or strings for that matter, you know? And like, you know, this is not the best example of this, but like this should not be one. This should be, it should have a name. Give these things a name. Like, and this comment, like without this comment, this one means nothing. Like this does not mean anything if this comment were deleted. What if, you know, somebody came in here and changed it to another number because they're like, okay, well, we don't want to react on the UI layer. We want to react on the sub UI layer because we have a menu open or something, right? Like, so they change this to a 2 and the comment ends up staying the same. Like all of these things work together to make your code very annoying to work with. So like don't have magic constants. Like this should be something like scene layer dot UI, right? And then you can just go ahead and define this thing. You can, you know, if you want it to be, there's a couple ways you could do it. You could do a static, like int, like public static int UI equals 1, right? So that's one way you could do it. But like, I would probably use an enumeration for this, right? So public enum special layers, and then, you know, something like UI equals 1, right? And then down here, you can just go to the end, special layers.ui, right? Now this code, and, well, that part is annoying, but there's ways around that as well. We're just going to cast it to init for now for this example, but like this has way more semantic meaning than just having a 1 there, right? And that's kind of what I want to get at. I don't know if that will fix it. I think you have to have like an implicit bummer. So we'll just keep it casted to init for now. We'll talk about implicit and explicit casts in another video. So I think that is about all I had. Yeah, that looks like it. And my dog is starting to whine now, so he probably wants out. So I'm going to go ahead and wrap up. If you guys like the stuff that I've kind of preached about here, give me a thumbs up and give me a like and maybe subscribe if you want to hear more of this stuff. There'll definitely be more videos coming. So that's all I got. I hope you guys have a wonderful day, and thanks for watching.